Okay. So today we are going to discuss chapter 23, Gauss law. It's one of the important chapters in physics too. And in this chapter, we are going to study some formulas. Generally, we are going to find the formula for different type of charge structures. Suppose if you have the line of charge, what should be the formula for calculating the electrical field? So we are going to study many formulas in this chapter, and in this chapter again we are going to study the concept of electric field. So all the formulas is related with the electrical field for different structures, different shape charge particle. So what are the content today we are going to discuss? We are going to discuss the definition for electric flux, and then if the electric flux is passing through area, because some case study we are going to study here, and then we are going to study the important topic Gauss law. So if you want to apply the Gauss law, what are the conditions you are going to take place, and then these are the application of the Gauss law. So by using the Gauss law, you can find the electrical field for infinite cylinder of charge. That means if the charge shape is like a line like structure, line type of structure of charges, if you have, then you can find some electrical field. So we are going to calculate this electrical field for this infinite cylinder of charge by using the Gauss law. Suppose if you have the plane of charge, you have to use Gauss law to find the electrical field. Suppose if you have the slab means it has some thickness. Plane means it's perfectly a sheet like structure, but slab means the sheet has some thickness. So we have some rules. By applying the Gauss law, you will get some electrical field. And then finally, if the shape will be in the symmetrical structure, so what calculation? What is the electrical field calculation? So these are all the topic today we are going to discuss. So we start with the first slide. What is the definition for electrical flux? So what is given in the box, you can just read. This is the definition for electric flux. So electric flux is nothing but the measure of number of electric field lines passing through a certain area. You can see this picture. I have green color line, and this green color lines indicates the electrical field lines. So this red color is nothing but my area. So when you place this area in these field lines, some number of lines will be passing through this area. The most important thing, if the lines will be exactly parallel to the direction of the normal of this area, then what will be the theta value? So the theta value will be designed by the area of the plane. So what type of plane? So in which position you are going to keep the plane? So the angle plays an important role. So the general definition for this electrical flux is nothing but we are going to measure the number of electrical field lines which is passing through particular area. So that formula is given as phi. So phi or phi. So this phi or phi indicates the electrical flux. The electrical flux should be used by the, it will be denoted by the symbol phi or phi. So either you can say phi or phi, both are correct. So what is the formula? The electrical flux phi, which is equal to electrical field, that means the vector product dot with area of the plane. So E dot A, we already studied the rule in chapter number 3, physics 1, the dot product and the cross product. What is the formula for dot product? A dot B is nothing but AB cosine theta in vector chapter, physics 1. So if you apply this A dot B here, E dot A becomes EA cosine theta. So here you cannot be able to use the sine component because this is a dot product. So this formula is used to find the flux, that means electrical flux calculation. So here what we are going to do, we have some 3 cases. So my dear, listen carefully. In this slide I have 3 pictures, and what are the cases? Suppose we are just good, because the theta plays an important role here. So if you want to get maximum flux, what should be the angle value? So here you can see the picture. I place the plane. So this is my plane. This gray color is my plane. I place the plane perpendicular to the electrical field lines. When I place this plane, that means this plane has some area. When I place this area of the plane perpendicular to the electrical field lines, you can see more number of flux lines, the electrical field will be passing through the area. So for example, the most important thing, the theta is 0 degree. Why it is 0? What is the reason for 0? You can see the plane normal is in this direction. My electrical field lines will be in this direction. So both are in the same direction. So what should be the theta? The theta will be exactly 0 degree. So when both the normal as well as the field lines will be parallel, then we have to say our theta is exactly 0. Clear, my dear? Clear?
Clear, doctor.
So when you have
Yes.
theta which is equal to 0, when you have theta which is equal to 0, substitute theta here 0. So when you put cosine of 0 is the maximum value. Am I right? So whenever your theta is exactly 0, you will get more amount of flux which will be passing through the particular area. Let's come for the second case. Now I place the plate exactly parallel to the electrical field lines. Now you can see the normal of the plane is exactly perpendicular to the electrical field lines. So the most important thing, the normal of the plane. So the black color, the thick line, you can see the arrow mark. So this thick line is exactly perpendicular to the field lines. You can see now if you place the plane here, how many flux will be passing through this plane? It's exactly same like the window in our house. If the window is exactly perpendicular to the direction of the wind, you will get more air. Am I right? Suppose if the window is parallel to the direction of the wind, did you get any air?
No.
No.
So the same concept, you can see here,
No, doctor.
my plane is exactly parallel to the direction of the plane. So no flux lines will be passing through the area. So when there will be no flux line is passing through the area, then you cannot be able to calculate the flux. So in such a case, here my theta, the theta is exactly based on the normal of the plane. So my normal of the plane is exactly perpendicular. So when the theta is 90, what will happen? If you put 90 degree, what will happen? Cosine of 90 is 0. So your flux will be 0. So the case, maybe sometimes you may get the question from the theoretical part. Suppose if the theta is 90, what should be your flux? You have to say my flux is 0. And the third case, it is not exactly perpendicular. It is not exactly to the plane. That means it is not exactly parallel. It is not exactly perpendicular. When you place the plane with some specific angle, that means the angle should be less than 90 degree. When the angle should be less than 90 degree, you will not get maximum flux. You will not get the zero flux. So you will get some amount of the flux, some amount of the electrical field lines will be passing through the area. Some of the lines will not pass. Some of the lines will pass through the area because we kept the plane with some specific angle. So these three cases is very, very important when you study the concept of this electrical flux. So when theta is equal to 90 degree, you will get no flux. When theta is exactly 0 degree, you will get more amount of electrical field lines. So when the more amount of electrical field lines passing through the area, then you will get more flux. Suppose if you make your plane tilted with some specific angle which is less than 90 degree, then you will get some amount of electrical field lines will be passing through the area. By the time it will not exactly maximum, it will not be exactly 0. So you will get the amount of flux will be some range. Clear, my dear?
Clear, doctor. Doctor, I have a question.
Okay. Yes, please.
Doctor, if it is more than 90 degree.
More than 90 degree, again, my dear, how it will be more than 90 degree? What type of angle you have?
I think negative. It will become negative.
Maybe negative value. Is it possible to get any values in negative?
No, doctor.
So meaningless, am I right or not? So if you just go to
Yeah,
180 degree, then cosine of 180 becomes negative value. So flux, you will never, all the times you will get some positive value. There will be no value of flux in negative. Clear?
Clear. Doctor, why the electric always in the right way? The electric.
Which one? Which one you are saying?
In every picture, we see the electric in the right way.
No, my dear, no issue. Whether it in the right hand side, generally, my dear, if you have the positive plate and the negative plate, your electrical, for example, if this plate has positive, if this plate has negative, all the lines, the field will be moving from positive to the negative. Clear? Clear, my dear? Yes, suppose if you want to make the direction of the electrical field lines in this direction, then consider this is negative, this is positive. Clear? Generally, we consider in the positive direction.
Doctor, electric, clear. Doctor, electric always in straight line or not?
It should be a straight line. It will not be a curved line. Whenever you have the charge, by the time it will be tilted with some curved lines. By the time you can find the direction. So we can find the direction of the curved surface. You have to draw a tangent line. We studied in chapter number 22. Do you remember that?
22.
Go back to chapter number 22. Suppose if you have the field lines, for example, if the field lines will be like this. For example, I have a charge. This is positive charge. This is negative charge. So what will happen? Your field lines will be going outward direction, and it will be entered the negative direction. Am I right or not? So
Like
in this
magnetic.
case, it will be the curve. If you want to find the direction, you have to draw a tangent line to the curve. For example, here, this is the direction of the electrical field lines. So here it is the direction of the electrical field lines. So we studied the concept in chapter number 22. But here we are studying the concept of uniform electric field. Your uniform electrical field will not be the curved, because whenever you have the curved field lines with positive charge and negative charge, what will happen? The positive lines will be more positive charge, the field lines will be emerging outward direction, and it will be entered in the negative charge. It's a dipole concept. Do you remember that?
Yes. Thank you, Doctor.
So here whatever the topic we studied is a uniform electrical field. Clear, my dear?
Clear, Doctor.
Okay. Now we come for this topic of Gauss law. It's one of the important topic, my dear. Before we go to the Gauss law, just please have a look of this picture. Here I have a picture with a egg-shaped structure, and here I have blue color lines. My dear, I have three surfaces. What are the three surfaces? You can see here. This is my first surface. This is my first surface. Am I right? And this is my second surface. These are all the Gaussian surface. So this is my Gaussian surface. And this is my third surface. And the final one is the entire surface. Clear? So how many surfaces you have? How many surfaces you have in this picture?
4.
4 surfaces you have. Now, my dear, the most important thing, another theoretical question. Keep this information in your mind. Whenever the field line is coming out of the surface, listen carefully, my dear. Whenever the field lines is coming out of the surface, it has positive. Clear? Clear? The flux is positive. Clear, my dear? Whenever the field lines is entering the surface, then your flux will be negative. And whenever the flux line will be entering and leaving, then your flux will be exactly zero. Keep this information in your mind. Okay. Let's see the first surface. What you understand by this blue color line? All the lines are coming out. Am I right?
Positive.
So your flux is positive for this. And you can see the second one. All the fluxes are entering this surface. Am I right?
Yes.
So what should be the value? Negative. Okay. Let's come for the third surface, my dear. What you understand from this surface? Your field lines are entering and leaving. Am I right?
Yes.
0.
So what should be the flux value? 0. Okay. Let's come for the outer surface, the big surface. You can see positive from the positive charge, the field lines are coming out, and after that it will be going into the surface of the negative charge. Am I right?
Yes.
So what should be the flux value?
0.
Very good. That's it. So keep this information in your mind.
Doctor,
Because we have one question in this chapter about this concept. Whenever the flux will be entering, it has negative. Whenever the flux will be coming out, it has positive. Whenever the flux will be entering and coming out, then it has the flux value 0. Clear, my dear? Clear?
Doctor.
Yes.
Doctor, could you please
Yes.
repeat this, because my connection. Could you please repeat?
Okay. Here in this picture, I have 4 surfaces. Surface 1, this. Surface 2, this one. Surface 3, this one. And the last surface is the complete surface. Orange color. Am I right? My dear, keep this information from first surface. You can see the blue lines, that means the electrical field lines are coming out. Am I right or not?
Yes, you are right.
Or not? So
Yes,
whenever
doctor.
the field lines will be coming out of the surface, your flux has the positive value. Clear?
Yes.
Clear? Whenever the
Yes,
flux
doctor.
line is entering the surface, you can see the second surface, all the lines are entering. Am I right or not?
Yes, Doctor.
So here your flux will be negative. Now you can see the third surface. Whenever the lines will be entering the surface, leaving the surface, then your flux value will be
0,
flux value
Doctor.
will be 0.
Zero.
And you can see the last surface, the entire surface, from the positive charge, the field lines are coming out, and then it will be going to the negative charge. So it is coming out, it is going in. So what should be the for the flux for the last surface? Again 0. Clear?
Clear, doctor.
Clear, my dear?
Clear.
Okay, now let's become for the Gaussian surface. Gaussian law. What is Gauss law says? You can see this is the definition, but we have the formula. Gauss law tells you about the amount of flux. So we already studied in the first slide. What is our flux, brother? Your flux, which is nothing but E dot A. Am I right or not? Am I right or not? We studied this in the first slide. And also your flux is exactly equal to, for example, you can see this surface, and inside the surface you have the charge. So you can find the flux, which is nothing but whenever you have the epsilon naught value, whenever the charge will be exactly sitting inside the surface, then that is also giving the information about the flux. Clear? What is this epsilon naught? This epsilon naught is the permittivity of the free space. I told you in the last class. What is epsilon naught, my dear? Permittivity. Because if one charge giving some energy to the another charge, sum of the charge, because we studied in chapter number 19, chapter number 20, no 100% efficiency. Do you remember that, my dear? Is any engine will give 100% efficiency?
No. No.
Likewise, if in the space, if you go to the space, there are numerous number of charges. One charges will giving the energy to the neighboring charge. For example, one charge giving 100% of the energy to the second charge. What will happen? While it traveling from the first charge to the second charge, this all the 100% will not go to the second charge. Some of the charges will be absorbed by the space. So that is nothing but epsilon naught. We have to say it's a permittivity. So it is the ability of the medium to store some electric charge. So that is nothing but your epsilon naught. Clear? Clear, my dear?
Doctor, which means we have two formula for electric fluids, right?
Flux. Electric.
Yeah.
So you have two formula for electric flux. But what I am going to do, if you want to write the Gauss law, you can see my left hand side of the equation is exactly the same. Am I right? So how I can write? I can write E dot A, which is equal to
Q over E.
That information is given here. You can see here, both are exactly correct. Why I just put the integration here? Because we have to take, because of small area, so I can just put this dA. I can put this dA. When you integrate with a Gaussian surface, this circle is denoting the Gaussian surface. So whenever you are applying the Gauss law, the most important thing, you have to draw the Gaussian surface. So the first thing, inshallah, next slide, I will tell you about how you have to apply the Gauss law. So the most important thing, whenever you are going to apply the Gauss law, you have to draw a surface and you have to keep some charges inside the surface. So this circle indicates the Gaussian surface. Clear, my dear? So generally what we have to do, no need to write like this. Even if you write like this, this will be the correct answer. EA, which is equal to Q over epsilon naught. This is also give the correct information, because once you integrate this dA, what should be the answer, my dear? It is A. Am I right or not?
Yes, doctor.
Yes. And the E is the constant term. You take it outside. So my E is outside. And if you integrate this dA, I will get A. So what is the total answer? EA, which is equal to Q over epsilon naught. Am I right or not? Am I right or not?
Yes, doctor.
Okay. Now this is the rule, because we know the formula flux, which is equal to EA, and also here we studied flux, which is equal to the charge which is sitting inside the inside the surface, and divided by the permittivity of the free space. My left hand side of the equations are exactly same, so I can write EA, which is equal to Q over epsilon naught. This Q is nothing but the charges which is sitting exactly at the center of the surface. Keep this information, and we are going to use this equation for the application purpose. Clear, my dear? Clear?
Clear, doctor.
Okay. Now, if you want to apply the Gauss law, I have 3 points here. You can see these 3 points. What is given in the first point? If you want to apply the Gauss law, you have to draw the Gaussian surface. My dear, when you draw the Gaussian surface, it must be a symmetric structure. What is the meaning for symmetric structure? What is the meaning for symmetric?
Like in the middle?
My dear, symmetric. Have you heard the word symmetry? Have you ever heard the word symmetry?
The same.
Symmetric and asymmetric. Have you studied?
Yes, in calculus.
Yes.
Okay, what is the meaning for symmetric? What is the meaning for asymmetric?
Right equal left, like same.
Symmetric means the left hand. For example, if you have some diagram, if you divide that into two parts, my left hand side of the parts must be equal to the right hand side. Clear? Clear?
Yes,
For
doctor.
example, I have a sphere. For example, I have the sphere. If I cut this sphere into two parts, what will happen? My left hand side of the portion of the sphere must be equal to the right hand side of the sphere. Am I right or not?
Yes.
So this is called a symmetric structure. So when you draw the Gaussian surface, you have to draw the symmetric surface diagram. So we are going to draw two types of symmetric. One is cylindrical type. One is cylindrical type. Another one is spherical type. So when you are applying this Gauss law, you have to draw these two types of surface. So either the surface should be in the cylindrical shape, and either the surface should be a spherical symmetric shape. So when you just draw the symmetric shape, then you will get a clear idea. So the first point, if you want to apply the Gauss law, the most important thing, you have to keep a symmetric surface, and whenever you draw the symmetric surface, the Gaussian surface, the charges must be exactly at the center. For example, you can see this picture. This is my charge. I have a positive charge here. Am I right? You can see the picture. I have a positive charge here. I just draw the Gaussian surface. You can see that orange colored dotted line. And this is my Gaussian surface. You can see I put my charge exactly to the center of the Gaussian surface. Am I right or not? Am I right or not?
Yes, you are.
So our first point is satisfied. Am I right? Let's come for the second point. What is given in the second point? My electrical field must be perpendicular everywhere at the Gaussian surface. You can see here, my dear, I have positive charge. So my field lines will be outward direction. And this orange color dotted is my Gaussian surface. Now you can see my electrical field will be exactly perpendicular to the Gaussian surface. You can see here, it is perpendicular. It is perpendicular. Am I right?
Yes, you are.
So
Yes,
your
doctor.
electrical field lines must be perpendicular to the Gaussian surface. That is your second point. Clear? Clear, my dear?
Very clear, doctor.
Okay. What is your third point? The magnitude of the electrical field must be constant on the surface. My dear, listen carefully. If you calculate the electrical field here, what should be, for example, in this point, I have the electrical field, for example, 50 Newton per Coulomb. 50 Newton per Coulomb. What should be the electrical field here?
15.
Suppose in this point I have 50. What is the point here? So here also 50.
50.
What is here? 50. Here 50. So that is the information for the third point. Clear, my dear? So if you want to apply the Gauss law, you have to follow these three conditions. What is our first condition? When you draw the Gaussian surface, you have to keep the charge must be exactly at the center of the Gaussian surface. And the second thing, your electrical field must be perpendicular to the Gaussian surface. And the third thing, the magnitude of the electrical field must be a constant throughout the surface. Clear? Clear, my dear?
Doctor, I have a question.
Yes, my dear. Ask your question.
When you said the magnitude of the electric field must be constant on the surface, can you
Yes.
go back to the circle?
Yes.
Does it, when you said 50 on
Okay.
each end or 50 on all of them?
For example, this is the orange color dotted is the Gaussian surface. What is the electrical field here? What is the electrical field here? What is the electrical field here? What is the electrical field? Because this is like a spherical shape, so your radius will be the same. Am I right or not?
Yes.
So if the radius will be the same, your electrical field will be constant throughout the surface. Am I right or not?
So it will be 50 for all of them.
A 50 for each and every point on the orange color line. You have orange color dotted line. If you measure the electrical field at each point on this Gaussian line, you will get the same value.
Understand? Yeah.
Clear? So let's come
Very
for the
clear,
proof.
yeah.
So here the proof is given. So because we have the rule, because the Gaussian law phi, which is equal to Q over epsilon naught. How we got these things? Because we know the law. E dot dA, which is nothing but E dA cosine theta. We studied this formula in the first slide, and this is the Gaussian law. But my dear, you can see this is a spherical in shape. So what I am going to do, I am going to integrate this equation for this spherical charge. So my electrical field is the constant term, so I take it outside. Am I right? Electrical field is constant. Am I right or not? So I take it outside. If you integrate this dA, what you will get, my dear? You will get A, and the right hand side you will get Q over epsilon naught. Am I right? So if you integrate this dA, what will happen? This will give A, and this becomes Q over epsilon naught. I am going to move this A to the right hand side of the denominator. So what I will get? I will get E, which is equal to Q over A multiplied by epsilon naught. Am I right? And you can see the picture. This is like a spherical shape. So what is the formula for the surface area of the sphere? We know the surface area of this is not area, this is surface area. I forgot to write. What is the surface area of the sphere? My surface area of the sphere is 4 pi r square. Could you please substitute the value here? E, which is equal to Q over 4 pi epsilon naught multiplied by r square. Am I right? So in another word, how you can write? E, which is equal to K Q over r square. Did you study this formula?
I think for column.
In chapter number 22, our first formula, electrical field due to a point charge. Do you remember that?
Yes, K equal 1 over.
K, which is equal to 1 over 4 pi epsilon naught. So I just write 1 over 4 pi epsilon naught as K, and Q is in the numerator, R square is in the denominator. And here, if you just to see the picture, this is a point charge, positive charge. So I can directly apply the Gauss law. So if you apply the Gauss law, you will get the same answer. So this is the alternate method how to find the electrical field. Clear?
Clear,
my dear.
Doctor.
Okay.
Doctor, do we need to apply the theta here, cosine theta?
Cosine, my dear, all the times your cosine, if you want to get the maximum flux, your cosine will be 0. The theta will be 0. Am I right or not? So whenever you are explaining some concept in physical, my dear, whenever you are just explaining the theoretical concept, all the times we have to make our theta as the greater value. When you will get the theta value as greater? When your theta is 0, cosine of 0 becomes 1. Clear?
Yes. Clear.
So we have to consider our theta value as 0. You can see here, I put my theta value is exactly at 0. Clear?
Clear, doctor.
Okay, let's come for the topic. Suppose if you have a conductor, what is the meaning for conductor? What is conductor, my dear? Anything which can conduct easily, which is nothing but the conductor. Am I right? Whether it is a heat energy, whether it is a electrical energy, so whatever it may be, it is comes under the conductor concept. Conductor is nothing but if any material which will conduct the charges, which will be conduct the electrical field or electrical energy, whatever it may be, then we have to say that object is a conductor. Now if you have the conductor, you can see here, my dear, I have the conductor. This is my conductor, this is my conductor, and you can see whenever you have the conductor, the charges will not exactly sitting in the center. So you will never have any charges at the center of the conductor. For example, I have the conductor. For example, here I just draw one-dimensional point of view. Suppose if you just see the conductor in the three-dimensional point of view, it has some thickness. So whenever you have the thickness of conductor, if you have the conductor have some thickness, you cannot be able to find charges exactly at the center. At the center of the conductor, the charges will be 0. If there is no charge, there will be no electrical field. So whenever you take the conductor, the charges will only come and sit only on the surface. The charges will never go exactly to the center of the conductor. Clear, my dear? Keep this is one theoretical. This is a theoretical concept. If you have a conductor, you have no charges exactly at the center. All the charges will be come and sit only on the surface. You can see the picture. My positive and negative charge is sitting only on the surface, not in the center. Am I right or not? Am I right or not?
Yes, doctor.
You can see the picture. All the charges will be exactly sitting on the surface only. You can see only in the surface there is a charge. There is no charges exactly at the center. So if you take any conductors, the charges will always sit on the surface, and inside the conductor there will be no charge. If there will be no charge exactly in the inside of the conductor, there will be no electrical field inside. So you will get electrical field only in the surface. Clear, my dear? Clear?
Yes.
Okay. Now let's we come for the infinite, because we have some application. What are the applications we have? We have line of charge. That means infinite cylinder of charge. We have the plane sheet of charge. We have slab of charge. We have spherical charge. So my dear, listen carefully. Don't get confused about this. I just written many information here. You can see only this picture. You can see only this picture. And I have infinite line of charge. You can see this charge is have some line. Am I right or not? Am I right or not? You can see the charges. Better I can just draw here. So better I can draw here, then you will get some idea. I'm going to take a line of charge which is infinite in shape. So I have line of, this line has infinite length. So all this is positive charge. I'm going to take this positive is have a line of charge. It have some length. Now, what I'm going to do, if you want to apply the Gauss law, what I told you, my dear, what I told you, you have to draw the symmetric shape surface. Am I right? Am I right?
Yes, you are.
So I'm going to draw the symmetric shape surface. So I'm for this line. So I'm going to draw the cylindrical shape. So this is my Gaussian surface, cylindrical shape surface. Clear? Clear, my dear?
Clear. Yes, Dexter.
Okay. And this is the length of the my Gaussian surface. So this is my length. And this is my
Victor,
it
it must be in the middle.
your charges must be in the middle. You can see my charges are exactly in the sitting exactly at the center of the surface. Am I right or not?
But there is a 3 charge outside and
Forget about the outside charges. We have to consider what are the charges which will be exactly sitting on the surface, Gaussian surface.
Yes, yes.
Forget about the charges which will be outside the surface. Don't worry about the charges outside. Okay, we have to consider how many charges will be sitting exactly on the surface. Clear?
Yes, okay.
Okay.
Clear.
Now, my dear, listen carefully. This is my length, and this is nothing but my radius of this. Am I right or not? Am I right or not? What is the surface area of the cylinder, my dear? What is the surface area of the cylinder?
2
4 by r square.
4 by r square.
My dear, 4 pi r square is for the spherical shape. This is the cylindrical shape.
Yes, 2 r square by multiplied
My
by
dear, this is like a circle. Am I right? This is the circumference of the circle. Am I right?
Yes,
So circumference of the circle is 2 pi r. Am I right or not?
yes,
And this cylinder has some length. Am I right or not?
yes,
So 2 pi r L is nothing but the surface area of the cylinder. Keep this information clear. Okay. Now what I am going to do?
square,
I am going to what?
no square and the r.
My dear, area of the circle is pi r square. Perimeter of the circle is 2 pi r. Don't get confused about this r square and r. Whenever you are going to find the area of the circle, this is pi r square. Whenever you are going to find the circumference of the circle, this is 2 pi r. But here we draw the structure of the cylinder. So cylinder, it's a top, it has some the circumference of the circle, and also the surface of the cylinder has some length. So 2 pi r multiplied by length is nothing but my surface area of the cylinder. Clear? Clear?
Clear.
Okay. Now, could you please tell me what is your Gauss law? EA, which is equal to Q over epsilon naught. Am I right?
Yes.
Okay. Take this A, substitute here. What you will get, my dear? Or you can do one thing. First, you move this A to the right hand side of the denominator. If you move, what you will get, my dear? E, which is equal to Q over A multiplied by epsilon naught. Am I right or not?
Yes.
Okay. Now you can see the charge. Here you have many charges. Some of the charges will be outside the surface and some of the charges will be inside the surface. Am I right or not?
Yes.
Am I right or not? So we have to consider only the charges which will be exactly inside the surface. So what I am going to do, here I am going to write the Q inside the surface. I am going to write the letter Q in. What is the meaning for Q in? Q in means the charges will be exactly inside the surface. Clear? Okay. Now what I'm going to do, we don't know how many charges will be exactly sitting in the surface. So I'm going to introduce the term, the linear charge density lambda. Lambda is nothing but linear charge density. What is the formula for linear charge density? Charge inside with respect to some length of the surface. So in this length, how many charges will be sitting, which is nothing but my lambda. Clear, my dear? In this length, how many charges will be sitting, which is nothing but my lambda, which is nothing but my linear charge density. Clear?
Yes.
Clear, my dear?
Clear.
Therefore, my Q in, which is equal to lambda multiplied by L. Am I right or not?
Yes, you are.
So what I'm going to do, I'm going to take this A, I'm going to substitute the value here, I'm going to take this Q in, I'm going to substitute here. So what you'll get, my dear? So I'm going to, better I can just erase this. Wait a minute. I can erase this line. I can take this A, I'm going to substitute the A here, and I'm going to take this Qn, I'm going to substitute here. Clear? So if you substitute, what you'll get? E, which is equal to, what is Q in? Lambda multiplied by L. And what is your area? 2 pi r L multiplied by epsilon naught. Am I right or not?
Yes.
Yes, you are.
So L get cancelled with this L. So what should be the electrical field? Electrical field for the line of charge, which is equal to lambda over 2 pi epsilon naught multiplied by R. This is the formula. You can go back to your slide. Did you got the answer? Clear?
Clear.
Clear, my dear? Is it clear or not? Open your
Clear.
mouth and say yes or no.
Yes, yes, doctor.
Yes, doctor. It's
Okay.
clear.
Oh, okay. Let's come for the second application. Infinite plane of charge. My dear, listen carefully. I have the plain sheet of charge. My dear, listen carefully. I have the plain sheet. Sheet means it's like a paper sheet. It's infinite shape. So this sheet has some charges. It's an infinite sheet. So don't get confused about this line, my dear. I tried to get this line, but some problem in the, so I have infinite sheet which have the charge. What type of charge? Positive charge or negative charge? You can see I have the infinite sheet which have positive charge or some charges which will be distributed uniformly. Now what you have to do, you have to draw a Gaussian surface. So what I'm going to do, I'm going to draw the Gaussian surface. So what type of diagram I'm going to draw? I'm going to draw the cylindrical shape. My dear, listen carefully. So this is my Gaussian surface. I'm going to draw the Gaussian surface. So which is my area? This is my area. This is the main area. Main area is this one. Okay, clear, my dear? Understand? Clear?
Yes.
Suppose if you have the positive charge, what will happen to the field lines, my dear? Your field lines will be coming outward direction. Am I right? It will be coming like this. Am I right or not?
Yes.
And this is like a area of the circle. What is the area of the circle? I have the area of the circle one side and I have another area of the circle in the right hand side. So what is the formula for area of the circle? What is the formula for area of the circle? Just before I told you.
By R square.
Pi r square. I have the area of the circle pi r square. Area which is equal to pi r square. How many area you have? Right hand side one area, left hand side one area, because in this area your electrical field lines is coming out of this surface. Am I right or not? This is our main surface. So from this main surface our field lines are coming out. Am I right?
Yes.
Am I right or not? Okay, now
Yes,
could you please
sir.
tell me what is your Gauss law? Could you please tell me what is your Gauss law, my dear? EA
equal
which
to
is
Q
equal to
over.
Q in over epsilon naught. Am I right?
Yes.
I am going to move this A to the right hand side of the denominator. So what you will get? E, which is equal to Q in over A epsilon naught. Am I right? Am I right or not?
Yes, doctor.
Am I right or not? How many area you have? 2 areas you have. Am I right? So I have to put 2. Clear?
Yes.
Now you can see the sheet. I have many charges, but inside the surface, how many charges will be sitting? Then we have to find the surface charge density sigma. What is the formula for surface charge density? Qn over area. In this area, how many charges will be sitting? We have to find. Therefore, my Qn, which is equal to sigma multiplied by area. Am I right?
Yes.
So I'm going to take this 2n, I'm going to substitute here, I'm going to take this area, I'm going to substitute here. So what you'll get, my dear? E, which is equal to Qn, which is nothing but sigma multiplied by area divided by 2 times of area multiplied by sigma. This area and this area get cancelled, and finally what you'll get? E, which is equal to sigma over
2 A naught.
epsilon naught. You can go back to your slide. Did you got the same answer?
Yes, doctor.
Clear?
Clear.
Clear?
Yes.
Okay. Now we go back to the slab of charge, because normally slab is considered for the conductor. My dear, see the picture. I can just draw the slab. You can see here I have a thick slab and which have some thickness, and this is a conducting material. So what I am going to do, I am going to draw the slab which has some thickness. And in this I have some charges, so I can just change the color. Oh my god. So here all the charges will be only sitting on the surface. Why my dear? What is the reason it is sitting on the surface?
Because there is a thickness.
This is the conductor. Just before we studied, if it is a conductor, all the charges will be sitting only on the
Surface.
Surface.
only on the surface. There will be no charges in the center. Clear? Now I am going to draw the Gaussian surface. So what type of Gaussian surface? I have to change the color, then only you'll get the Gaussian surface. So I can just take this green color. So I'm going to choose only the particular area. And in this area, I have to draw the Gaussian surface in the form of cylinder, because I told you whenever you draw the cylindrical shape or spherical shape, it's depend upon the structure. So you can see here, my dear, you have only charges and in this area. You can see this color. You can see I can change the color. Here I have only charges only in this surface. So this is my surface. Am I right? Am I right or not?
Yes, you are.
Is there any charges?
Yes.
Is there any charges here? Is there any charges here?
No, doctor.
Is there any charges here? Because this
No,
is a
no,
slab.
no.
So no charges. So no field lines will be coming out. So only your field lines will be coming out of this area. Am I right? Because of the charges positive. Am I right?
Yes.
Yes.
Okay. Now, could you please tell me what is your Gauss law? E, which is equal to, EA, which is equal to Q in over epsilon naught. Am I right? Therefore, my E, which is equal to Q in over A multiplied by epsilon naught. And what is your area? Because this is like a area of the circle, and through this circle your electrical field line is coming. So what is your area? Pi r square. Am I right? Am I right or not?
Yes, doctor.
Yes.
Okay, now what is Qn? Surface. In this surface, how many charges are sitting? We have to use the sigma, which is equal to Qn over area. Clear? Therefore, my Qin, which is equal to sigma multiplied by area. So now what I'm going to do, I'm going to take this formula, I'm going to substitute here, I'm going to take this Qn, I'm going to substitute here. So if you substitute, what you will get, my dear? E, which is equal to sigma A divided by, already one more A in the denominator, epsilon naught. So what will happen? This A get cancelled with this A, and finally you will get the answer sigma over epsilon naught. So this is the formula for the thick slab of charge. Did you get the same answer? Did you get the same answer?
Yes, Doctor.
Yes.
So please, my dear, don't get confused about the plain sheet of charge and slab of charge. Slab of charge, it is sigma over epsilon naught, but plain sheet of charge, it is sigma over 2 epsilon naught. Clear, my dear? Understand?
Yes.
Okay, now the most important topic, my dear, we have one question from this slide. Suppose you can see the picture, my dear. My dear, now I need the answer from your side. Now I need the answer. I can just change the color to red color. Then only I can draw the picture. You can see here, I have two sheets. One sheet with positive charge, another sheet with the negative charge. And here, this is my surface area. And here I have surface area too. Clear, my dear? Understand, my dear? Okay, now what will happen? I am going to take a positive charge or negative charge. If you want to take positive charge or if you want to take the negative charge, both will give the same answer. Clear? Okay, now I have three locations. One is left hand side of the first plate. So I can take, this is my first plate, this is my second plate. Clear? Clear, my dear?
Yes, Doctor.
Clear?
Yes, Doctor.
So the first
Yes,
plate has
yes.
the positive charge and the second plate has the negative charge. Am I right? Now what I am going to do, I am going to place the positive charge left hand side of the first plate. Now what will happen? We have to find the direction. My dear, I need the answer from your side. I place the positive charge here. This is my positive charge. Positive charge, when it reacts with positive charge in the first plate, what will happen?
Repel.
Positive
Ripple.
ripple. So my direction of the line will be left hand side. Am I right?
Yes.
Yes.
Okay. Now positive charge, when it reacts with the negative of the second plate, what will happen?
Attract.
Tract.
So my lines will be here. Am I right?
Yes.
So one line is in the left hand side direction, another line will be the right hand side direction. So what should be my electrical field at the left hand side?
0.
0.
0. Okay, let's come for the right hand side. I'm going to place the same positive charge in the right hand side of the second plate. Now positive charge, when it reacts with the first plate, positive charge, what will happen?
Repel.
So my line will be going here. Am I right?
Yes.
When the positive charge react with the negative of the second plate, what will happen?
Tract.
Tract.
So this will be in the left hand side direction. So you can see the line. One line is in the right hand side direction, another side in the left hand side direction. So what will happen? So in the right hand side, what is my electrical field?
صحيح ما رسلت لنا
Zero.
النوت توني ارسلتها لها اليوم تذكرت.
What happened? What you are saying, my dear? I don't know. You are saying something in Arabic. I don't know.
Continue, Doctor.
Okay, now let's come for the middle. I'm going to place the positive charge here. What will happen, my dear? Based on the positive charge with the first plate, what will happen? What will happen? I
Where
place
the-
the positive charge at the center. Based on the positive charge with respect to the first plate, what will happen? It will repel. Am I right?
Repel. Yes.
Okay. Based on the positive charge with the negative charge, what will happen?
Tract.
Tract.
Same
So
direction.
both lines will be the same direction. Am I right?
Yes.
Yes.
So each plate has 5 sigma over 2 epsilon naught. So you will get some electrical field here. So in between the plate, what should be your electrical field? Your electrical field is sigma over epsilon naught. Clear, my dear?
Yes,
Clear?
Doctor.
So this
Clear.
condition is only applicable for but two plates with different charges. So when you have one plate positive charge, one plate negative charge, you will get the electrical field only at the center. There will be no electrical field at the left hand side of the first plate, right hand side of the second plate. Clear? Clear, my dear?
Yes, Doctor.
Understand?
Clear, Doctor.
Okay, let's come for the second picture. I have two plates with the same charge. Either you can say positive, positive or negative, negative. No issue. The answer remains the same. Now, I'm going to place the positive charge here. What will happen, my dear? What will
It's
happen?
repel.
I put the positive charge. Based on the first plate, what will happen?
Repel.
Repel.
It will be repel. Very good. Okay. Based on the positive charge with the second positive charge, what will happen?
Repel
repel.
also.
So both lines will be in the left hand side. So in this place, my electrical field E, which is equal to sigma over epsilon naught. Am I right? Am I
Yes,
right?
you are.
Yes.
Okay, let's we come for the right hand side. I place the positive charge here. What will happen? This positive charge reacts with the first plate. What will happen?
Rebel.
Rebel.
And based on this positive charge from the second plate, again it will be repel. Both lines will be same direction. So what will be the answer? Sigma over epsilon naught. Am I right?
Yes.
Yes.
So this sigma over epsilon is the positive direction, and this sigma over epsilon is the negative direction. So you can put only the sign different. Okay, let's become for the middle. I am going to put the positive charge in the middle. What will happen? Positive charge, based on the positive charge with the first plate, what will happen, my dear? It will
Rebel.
repel. Am I right?
Rebel.
Yes.
Yes.
Based on this positive charge with the second plate, again it will be repel. The line will be like this. Am I right or not?
It will be 0.
Yes.
So please, my dear, listen carefully. If both plates have the same charges, there will be no electrical field in between them. Clear? If you have two plates with different charges, you will have some electrical field in the middle. Clear? Clear?
Yes. Clear.
Keep this point in your mind, because we have one problems based on this concept. That's what I'm taking more time for these slides. Clear? Understand?
Yes, doctor.
Okay. Now let's we come for our last topic, my dear. Generally, we have two types of spherical charge. One is conducting sphere. Another one is
Insulate.
insulating sphere. Clear? Suppose conducting sphere, you have the sphere. What will happen to the conductor, my dear? All the charges will be sitting on the surface. Am I right?
Yes.
Am I right or not?
Yes.
Yes, doctor.
Is there any charges inside?
No.
No.
No. So in such a case, you will have the electrical field, because we already studied this concept. E is equal to KQ over R square. I don't want to take more time. So I want to explain the easiest way. If you have the conducting sphere, all the charges will be sitting on the surface. So in such a case, electrical field for that charge is E is equal to KQ over R square. Clear, my dear? Understand? If there is no charges inside, what should be your electrical field at the center?
0.
0. So no use. But when you come for the insulating sphere, my dear, listen carefully. It's a very, very important concept. But we don't have any question from this insulating, but we must know the difference. That's what I'm just taking some time. My dear, don't get confused about this line. I have the insulating sphere. In insulating sphere, what will happen? The charges will be sitting on the surface as well as
Inside.
inside. My dear, listen carefully. This is one of the important topic. Maybe theoretical question we can ask, but we don't have any formula related with this insulating sphere. So in such a case, whenever you want to find the sphere, the charges outside the surface, again the formula will be the same like conducting sphere, but inside the surface, what will happen? You have the electrical field KQR over AQ. Clear? But we don't have any formula for this. So don't worry about the insulating sphere, but you have to consider only the formula E, which is equal to KQ over R square. Clear, my dear? Clear?
Yes, doctor.
Understand? But when you study the concept of insulating sphere, we will study one concept which is nothing but the volume charge density rho. What is volume charge density? Amount of charge which will be sitting inside the volume. Because we studied 3 charge densities. Am I right? What are the 3 charge density we studied, my dear? What are the 3 charge density we studied just before? Just recall. What is lambda? What is lambda? Linear charge density. What is sigma? Surface charge density. What is this rho? This is volume charge density. What is the formula for linear charge density? Q in over L. And what is the sigma? Q in over area. What is this rho? Q in over volume. But we don't have any formula for this. But anyhow, sometimes in the theoretical question, we may ask the formula. what is the formula for volume charge density. But we don't have any problems related with this insulating sphere. That means with this formula. Clear? Clear, my dear? Actually, this formula is only applicable for the insulating, because it is not applicable for the conducting sphere. Because why? Inside the conductor, there will be no charge. So if there is no charge, there will be no electrical field. But when you come for the insulating sphere, inside the surface, also you will have some charges. When you just find, you will have this formula. That explanation is given clearly here, but I don't want to waste the time because we don't have any question related with this insulating sphere. Clear, my dear? Understand?
Yes, clear.
Clear? That's it. Chapter is over. So could you please recall the formula? Could you please recall the formulas? What is flux?
1, 3.
Flux which is equal to EA. Am I right? And
Yes.
another flux which is equal to Q in over epsilon naught. Am I right? What is Gauss law? Gauss law, which is nothing but EA, which is equal to Q in over epsilon naught, or you have to write integration the closed Gaussian surface E dot dA, which is equal to Q in over epsilon naught. Both are same. Clear, my dear? But generally, if you have any theory question, please write this formula. In general, actually, when you just integrate, you will get the same answer. Clear? Understand, my dear? Understand?
Yes.
Okay. What is the formula for linear charge density? If you have a line of charge, you have lambda over 2 pi epsilon naught r. If you have a plain sheet of charge, you have sigma over 2 epsilon naught. If you have slab of charge, electrical field which is equal to sigma over epsilon naught. And if you have a spherical shape, outside the sphere, you have electrical field k q over r square. But inside the sphere, but we don't have any question related this, but anyhow we can write the formula k q r over a q. Clear, my dear? But we don't have any problem, so don't worry about these things. Okay, what is the formula for lambda? Q in over L. What is the formula for sigma? Q in
over A.
over area. And what is the formula for the rho? Q in over
V.
volume. But we don't have any problem related with these two formula, so don't worry. Clear, my dear? Understand? Understand?
Yes, doctor.
Okay, by using these formulas, what we are going to do, we are going to solve these 5 problems, 1, 3, 16, 20 and 35. My dear, now I need the answer from your side. What happened? Now I need the answer from your slide, from your side. So please give your response while I solve the problems. Clear? Clear? Why no response from your side?
Yes, doctor.
Sleeping, huh?
Clear.
Sleeping, huh?
Yes, doctor, clear.
Clear.
Okay. Now, read the question. Read the question. Still we have 15 plus 10, 25 minutes I have. So I can finish my problem here today, inshallah. Okay. Read the question. An infinite line of charge. So what is the question related with? What is the question related with?
Fine.
Line of charge. That means the formula E, which is equal to lambda over 2 pi epsilon naught multiplied by r. So this formula, because this formula is related with line of charge or cylinder of charge, both will be the same. So what is given in the question? You have the line of charge which produce the magnitude 1.7 multiplied by 10 to the power of 4 Newton per Coulomb at a distance 9 meter. So better I can draw the diagram, then you will get some idea. So I have the line of charge. I have the line of charge which have some charges, which is line. So because I draw the line in the vertical form, and it produces magnetic field, electric field at a distance. So from this line of charge to a distance, what is my distance, my dear? What is my distance? 9 meter. In 9 meter, what is my electrical field? 1.7 multiply by 10 to the power of 4 Newton per Coulomb. Clear? Clear, my dear? In this distance, 9 meter, and in this point of 9 meter, what is my electrical field? 1.7 multiplied by 10 to the power of 4 Newton per Coulomb. Now, what we are going to do, if the distance is 2 meter, what should be the electrical field? That means my distance is 2 meter. For example, 2 meters here. Am I right? Am I right or not?
Yes, yes.
Now, what I am going to do, I can name. This is my R1. This is my E1. This is my R2. This is my E2. So our main concept, we are going to find the value of E2. So what I am going to do, I am going to apply this rule. I am going to apply this rule for this set, and also I am going to apply this rule for this set. So what you will get, my dear? Apply the rule for the first set. What you will get? E1, which is equal to lambda over 2 pi epsilon naught R1. Am I right? So I can just name this is my first equation. Understand?
Yes.
Apply the same rule for the second set. E2, which is equal to lambda over 2 pi epsilon naught R2. So this is my second equation. My dear, listen carefully. Whenever the distance will be shorter, your electrical field strength will be greater. Am I right?
Yes.
Whenever the distance will be more, your electrical field strength will be weaker. So when you are about to finish this problem, your answer for this E2 will be greater than E1. Am I right or not?
Yes.
Okay. Now I'm going to divide equation 1 with equation 2. So sorry, equation 2 by 1. So what I am going to do, I am going to divide the second equation by first equation. What you will get, my dear? Could you please divide second equation by first equation? So left hand side I am going to divide. So what you will get? E2 over E1, and then like that, this divided by that. So what you will get? Lambda over 2 pi epsilon naught R2 divided by lambda divided by 2 pi epsilon naught R1. Am I right? Am I right or not?
Yes.
So expand this equation, simplify, because when you just expand, then it will be very easy. So what I am going to do, lambda over 2 pi epsilon naught R2 multiply by, this will come to the numerator, this will come to the denominator. Am I right? So 2
Yes.
pi epsilon naught R1 divided by lambda. Am I right? You can see this lambda get cancelled, and this 2 epsilon naught cancel. Remaining, what you will have? You will have E2
R1
over
R2.
E1, which is equal to R1 divided by R2. Now what is our aim? We have to find the value of E2. Am I right? Therefore, my E2, which is equal to E1 multiplied by R1 over R2. Am I right? Am I right or not?
Yeah, yeah.
What is the value of E1? E1 is already given. What is the value? 1.7
1.7
multiplied by 10 to the power of 4. Am I right? And what is your R1? It is 9. What is the value of R2? It is 2.
2.
When you substitute the value here, you will get the answer for E2. Am I right? The unit will be Newton per Coulomb. Clear?
Okay.
Clear, my dear?
Doctor,
Yes.
I have
Yes.
Yes, please.
You mentioned that we divided the second equation over the first one because the electric field will be bigger. Is it because of R?
My dear, even if you divide 1 over 2, our ultimate aim is to find the value of E2. Am I right? If you divide 1 by 2, you will get 2 more steps extra.
Oh, okay. So there is no
Clear?
difference.
For your easiest purpose, I divided 2 by 1. Or if you want to divide it 1 over 2, then you will write 2 more steps extra. That's it. Your answer remains the same. But why you are wasting your time?
Okay, and Doctor, I have another question.
Yes, please, ask your
The
question.
electric field will be bigger because of R, right? Because R is smaller.
Yes, whenever the distance will be shorter, your electrical field strength will be greater. Whenever the distance will be greater, your electrical field strength will be weaker. We already studied this concept in chapter number 22. Do you remember that?
Yes, I'm just making sure.
You can just work out for sure your answer will be greater than E1. Could you please work out and let me know what is your answer? If you have a calculator, could you please tell me the answer? Please, my dear, don't see my answer. You have to work out by yourself. Just tell me the answer. Just take your calculator and please simplify this. Let's compare the value of E2 with E1. Just tell me the answer.
76500.
That means 76500. Am I right? Okay, in terms of
Yes.
power, I can write 7.65 multiplied by 10 to the power of 4. Am I right?
Yes.
What is your E1? You can see E1. It is just 1.7. But here, what is your E2? Which one
It's
is
a lot
greater?
bigger. The second one.
Why? Why it is
E2.
greater? What is the reason?
Because of the
Because it's
distance.
closer.
Because it is only 2 meter distance. So 2 meter distance, your electrical field strength will be stronger. Clear?
Yes, clear.
Okay. Shall I go to the second question?
Yes.
Okay. It's very easiest chapter, my dear. And please, the only thing you have to recall the formulas. Formula is only very, very important. Read the question very carefully. What is given in the question? You should read each and every word very carefully, my dear, especially for this question. What is given in the question? An unknown charge sit on the conducting sphere of radius 10 centimeter. That means you have the conducting sphere. My dear, you have the, I can just delete this, sorry. You have the conducting sphere. So I have a conducting sphere. I can just draw the sphere here. I have the conducting sphere. What is the sphere radius? Sphere radius is given. So what is the radius? Small r, which is nothing but
30 centimeters.
10 centimeter. Okay, sphere. And you have some charges sitting on the surface. And if the electrical field is 30 centimeter from the center to the sphere, my dear, from the center to 30 centimeter, from the center to 30 centimeter. So this is my 30 centimeter. Clear? And in this 30 centimeter, you have some electrical field here. What is your electrical field? 3 multiplied by 10 to the power of 3. And what is your distance? R, which is equal to?
30
R, which is
centimeters.
equal to?
30 centimeters.
My dear, don't get confused about the small r and the capital R. Small r tells you the radius of the sphere, and capital R is the distance from the center to where you have the electrical field. Clear? Understand?
Yes.
Yes, Doctor.
Okay. And then it is radially inward. My dear, your field lines are inward direction. Your field lines are inward direction. What is the meaning for inward? You have some charges with inward direction. So what type of charge is sitting on the surface of the sphere? Positive charge or negative charge?
Negative charge.
Why it is negative charge? What is the reason?
Because the direction is inward.
Because the electrical field lines is radially inward. If it is outward, the charge is, because we don't know the charge, whether it is positive or negative, but they give this information. So based on this information, we clearly know this unknown charge is
Negative.
negative. Clear, my dear?
Yes. Yes, clear.
Okay. Now, what we are going to find? We are going to find what should be the value of the charge. What should be the net value of the charge? That means in the first question, we are going to find the value of the charge. And the second question, what we are going to find? We are going to find the charge density. My dear, if you have the sphere, then it's something says about the surface charge density. They just give only the charge density. So you should think, because we studied 3 charge density: linear charge density, surface charge density, volume charge density. And here, according to the question, the charge is sitting only on the surface, not inside. Am I right or not? And it is a conducting sphere. Do you get my point?
Yes.
Yes, Doctor.
Okay, so that is nothing but your sigma. Okay, for first finding the value of Q, what should be the formula for the sphere? Just before we wrote the formula, for the conducting sphere, what is the formula, my dear? What is the formula here? What is the formula?
Cake over
Electrical field which is equal to KQ over R square. So I am going to use this formula for the first part because that is the formula for the electrical field for the conducting sphere. E which is equal to KQ over R square. Clear? It's not small r. According to this diagram, this is capital R. Okay? Understand? Because our electrical field distance is capital R according to this diagram. Clear, my dear? Understand?
Why, Doctor? Why?
My dear, electrical field is at a distance of 30 centimeter. Am I right or not? So what should be your R? Small r or capital
yes.
R?
Yes, clear.
Clear? Okay, now we are going to find the value of Q. Therefore, if you rearrange this equation, Q which is equal to E multiplied by R square divided by K. K is the constant. So you know the E value. What is the E value? Which is already given in the question. 3 multiplied by 10 to the power of 3 Newton per Coulomb. Am I right? Am I right or not? So substitute the value. Q which is equal to 3 multiplied by 10 to the power of 3. And what is my R? 30 centimeters. So I have to convert it to meter. So I have to square. And the K value is a constant. 8.99 multiplied by 10 to the power of 9. Could you please tell me what is the answer, my dear? Could you please tell me what is the answer? Please work out by yourself and please let me know what is the answer. Let's check the answer. 3 multiplied by 10 to the power of 3 multiplied by 30 10 to the power of minus 2 square divided by 8.99 10 to the power of plus 9. What answer you got? I got 3.0 multiplied by 10 to the power of
8 minus 8.
minus 8. Okay, my dear, I got the value of the charge, but what is the sign of the charge? Because we said this is a negative charge. So how I have tried? Q which is equal to, understand?
Yes.
Clear? Okay, now this is the answer for the first question. What is my second question? Second question, I have to find the value of surface charge density Q which is, sorry, sigma which is equal to Q divided by
Area.
surface area of the sphere. So what is my Q? I have to take this Q, I have to substitute here. Minus 3 multiplied by 10 to the power of minus 8 divided by, what is the surface area of the formula? 4 pi R square. So 4 multiplied by pi multiplied by small r, that is nothing but the radius of the sphere. What is my radius, my dear? 10 multiplied by 10 to the power of minus 2 the whole square. Could you please tell me the answer? What answer you got? Just tell me the answer, my dear. What answer you got? 3 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by 10 10 to the power of minus 2 the whole square. What answer I got?
Minus 2.38.
Minus 2.38 multiplied by 10 to the power of minus 7. What's the unit? Q over A. What is the unit for Q? Coulomb. What is the unit for A? Meter square. So this will be the answer for the second question. Clear?
Clear.
Clear?
Yes.
Understand?
Yes.
Doctor,
Yes.
if it's a circle, we will use lambda equal to Q divided by L, right?
Lambda over?
If it's a circle, we will use lambda equal to Q divided by.
My dear, this is a sphere. Sphere have some volume.
No.
How you can use the lambda here?
I mean, if it's a circle, if we have a circle.
What type of circle?
I mean, when we have
Yeah.
a sphere.
If it is a line of charge, then lambda which is equal to Q over L. Okay.
Yes. Okay.
Okay. Let's come for the third question. Third question is very easy. All the questions in these chapters are very easy, but one thing you have to read and get the information. What is given in this question? 2 large metal plates. So I have 2 large metal plates. I can just draw the large plates. So I have 2 large metal plates, which is separated by distance 6 centimeters. So what is the distance separated by this? Clear? And each plate has area. What is the area, my dear? 1 meter square each. So each plate is 1 meter square. And then it has the charges but opposite sign. What is the meaning for that, my dear? Each plate has the equal charge magnitude but opposite sign. That means it has the positive charge, it has the
Negative charge.
negative charge. So in between these plates, you have some electrical field. What is that electrical field value? Which is already given in the question, 72 Newton per Coulomb. Because we studied one plate with positive, one plate with negative, you have only electrical field at the center. Am I right or not? We studied in the slides. Do you remember that?
Yes, doctor.
Okay, now what we are going to do, we are going to find what should be the value of the charge. So what I am going to do, we know the formula for the electrical field. What is the formula for the electrical field? Which is nothing but sigma over epsilon naught. Am I right? So first I am going to find the sigma and then I am going to find the A charge, because we don't have any formula, direct formula for this question. So first I am going to find the sigma by using the electrical field formula. Once I got, I am going to use the surface charge density formula to find the charge. So could you please rearrange this equation in terms of sigma? Sigma, which is equal to E multiplied by epsilon naught. So what is my E? Electrical field is already given in the question. 72 multiplied. This is a constant value which will be given in the question, in your question exam paper. So don't worry. Constant epsilon naught 8.85 multiplied by 10 to the power of minus 12. This is the permittivity of the free space. When you substitute the value, you will get the answer for the sigma. Am I right? Am I right or not?
Yes, doctor.
Yes.
And once you find the sigma, because our main information, we are going to find the value of the charge. So we have the formula for the sigma. What is the formula for the sigma? What is the formula for the sigma? Q over area. Am I right? Am I right or not?
Yes.
Therefore, Q, which is equal to sigma multiplied by area. Am I right? Am I right or not?
Yes.
Yes, and we have
And the
sigma.
area is already given. Area is already given 1 meter square. So after you got this answer, take the answer, substitute here, and the area of the metal plate is given as 1 meter square. So multiply this one, you will get the answer of the Q, and unit is Coulomb. Am I right? Am I right?
Yes.
Clear?
So,
Yes,
doctor, the
clear.
density equal to the
Equal to the?
this question.
Yeah, whatever the answer you got as a surface charge density, it will be the same, because when you multiply with 1, you will get the same answer. But the concept, they ask only the charge, not your surface charge density. Clear? Could you please tell me what is the answer here? 72 multiplied
6.5.
by 8.85, 10 to the power of minus 12. I got 6.372. Am I right? 6.372 multiplied by 10 to the power of minus 10 Coulomb per meter square. And when you multiply this value with 1, again you will get the answer as
Same.
6.372 multiplied by 10 to the power of minus 10 Coulomb. Because when you multiply this value with area, because area is given as 1 meter square, when you multiply with this one, you will get the same answer. Clear? Understand?
Clear. Yes.
Okay, let's go for the fourth question. What's the time? Oh, still we have 5 minutes. I can finish this question, and then the last question we will discuss tomorrow. My dear, this question is exactly from this slide. My dear, this question is exactly from this slide. What we studied from this slide? What we studied from this slide? If you both charges will be positive, center of the plate, you will get the electrical field 0. Left hand side, you will get some value. Right hand side, you will get some value. Am I right? Am I right or
Yes.
not? You can see the picture. Same concept. You have 2 plates. You can see here, you have 2 plates. One plate is positive, another plate is positive.
The electric
What will
field
happen, my dear?
between them
And
is
they
equal
give the
to
clear
0.
information about this is your x-axis, this is your y-axis. Am I right? My dear, if this is y-axis, what is this? This is y prime. Am I right?
Yes.
Am I right or not? So now they need the answer. So what you are going to do, you are going to find, because read the question, This figure shows the cross section of two large parallel non-conducting sheets with identical distribution of positive charge with a surface charge density sigma. Sigma value is given. What is that value? 2.31 multiplied by 10 to the power of minus 22 coulomb per meter square. In unit vector notation, you have to find the electrical field at the top of the plate, electrical field between them, electrical field below them. Clear? So you are going to find electrical field here, you are going to find electrical field here, you are going to find electrical field here. Clear, my dear? And we already know what should be the electrical field at the center?
0.
0. But what should be the electrical field at the top? Let's we just work out, because we have the formula E, which is equal to sigma over epsilon naught. What is your sigma? Sigma is already given 2.31 multiplied by 10 to the power of 22 divided by constant value 8.85 multiplied by 10 to the power of minus 12. Could you please tell me the answer, my dear? Could you please tell me the answer? 2.31 10 to the power of minus 22 divided by 8.85 10 to the power of minus 12. So I got, what is your answer?
2.6.
2.61 multiplied by 10 to the power of minus 11, and unit is Newton per coulomb. My dear, they need the answer in terms of unit vector notation. My dear, top, see the picture, see the graph as well as the picture. This is in positive y direction. Am I right? Am I right or not?
Yes.
What is the unit vector for positive y axis?
What is it?
2.61 multiplied by 10 to the power of minus 11 j cap. We studied in vector concept. Am I right? Am I right or not? Am I right or not? Tell me the answer.
Why, doctor?
Yes, doctor.
Can you repeat it?
My dear, x axis I cap, y axis j cap, z axis k cap. Did you study it in vector chapter, physics 1?
Yes, yes.
So this is in terms of diagram. You can see the diagram of the picture. You can see this is y axis, this is x axis. So what is the bottom? It is negative of y axis. Am I right?
Yes.
So according to the first point, this is exactly in the positive of the y axis. Am I right or not?
Yes, you are.
That's what we put j cap. Okay, what should be the answer for the center one? There will be no electrical field. So what should be your electrical field here? 0. Am I right? Between. Am I right or not? What should be the
Yes.
answer for the below? You will get the same answer like this, but what should be the sign?
Negative.
Why? Because in the negative of y axis. So I have to put negative, then I have to put j cap, and the unit will be Newton per coulomb. Clear? Clear?
Yes.
Clear.
That's it. So far we finished 4 problems. Inshallah, tomorrow we have 1 period, and by the time I will finish the 5th problem, and then I will start chapter 24. Chapter 24 is already in the blackboard. Please, my dear, have a look before you come for the class. Clear? Understand?
Yes.
Oh, my dear, actually today our class will be finished by what time? 140 or 150?
Yes, 150.
140. No, 140, because at 12:10 and the second period you have 10 minutes. So 140, correct. Clear?
Yes, doctor. Thank you.
So I think the
Okay,
class is over
doctor,
today.
okay.
So
Thank you,
the
doctor.
class is over today. Inshallah, we will solve the last question by tomorrow. And inshallah, after I finish, I will start chapter 24. Clear, my dear? Clear?
Clear, doctor.
Okay, doctor.
Okay, my dear, listen carefully. I will tell you 2 information. My dear, if you want to know your mistake in midterm exam, 2 options are there. Either you can discuss in the discussion class. In the discussion class, I will not show your paper. I can just tell where you made a mistake. Suppose if you want to see your paper, then you can come to the lab class. By the time come to my office, I can show your paper. Which one is perfect for you? You can decide by yourself. Clear?
Okay, thank you, doctor.
Clear, doctor.
In the discussion class, I can tell you only your mistake. But if you come to the lab class, Suppose, doctor, I want to see my paper. Then you can come to the lab class. After you finish the lab class, come with me. Then I can show your paper. Clear?
We slap box.
Clear, my dear?
Getting low, you know, I'm
Clear,
fast.
doctor.
Thank you so much.
Understand? Okay, my dear. Thank you so much. Inshallah, we will meet tomorrow.
You know what I'm saying? Slapping him. You know, so
Teacher.